In this video, I'm going to record inverse functions. So what specifically we're gonna cover? So we are going to cover verify inverse functions, then find inverse of function, and then I will go through horizontal line test for inverse function, and finally we will learn how to graph inverse functions. Okay, let's start. Identifying inverse functions or verifying if two functions are inverse. Algebraically. Okay. So, here is the rule. We have f of x and we have g of x functions, two functions. So, if f function composite with g function, which is f of g of x, is equal some value of a, it could be expression or can be one value, it doesn't matter, whatever it is equal to. And at the same time, g composite with f, which is g of f of x, equal to the same a, then, hence, this is the symbol of hence, we can say that g of x is inverse of f of x. Okay? And vice versa, that f of x is inverse of g of x. Okay? So practically we are going to take a composite of f composite with g, and then g composite with f, and if we get the same result, then these two functions are inverse. So let's take example. Let's assume f of x is equal 4x minus 7 and g of x is equal x plus 7 over 4. So let's take first f composite with g of x, and then we will take g composite with f of x. So f composite with g of x is equal f of g of x, where let me see, g of x is equal 4 times f of g of x is equal 4 times x plus 7 over 4. So what am I doing here? I'm taking again this g of x, plug here, because I have here g of x, see? F of g of x. So minus 7 is equal 4 times x plus 7 over 4 minus 7. 4 and 4 cancel. X plus 7 minus 7, it's gone, is equal x. All right, now let's take composite g with f of x, which is equal g of f of x. So now the opposite way, we are taking f of x and plugging to g of x right here, which is gonna be 4x minus 7 plus 7 over 4 is equal 4x minus 7 plus 7 over 4. Negative 7 is gone, negative 7 equal 4x over 4. 4 and 4 gone is equal x. So as we can see, both cases we have it equal to x. Therefore, we can insist that f of x is inverse of g of x, and g of x is inverse of f of x. Okay? All right. This is how we're gonna find if two given functions are inverse or not. Moving to next step, find the inverse function. Okay? Find the inverse function. We are given y is equal f of x, which is 2x plus 7. So to find the inverse function, we need to switch x with y. Wherever x I will replace with y, wherever is y I will replace with x. So at this point I'm writing x is equal 2y plus 7. And I need to find y from here. And that y that I will find will be inverse of f of x. So let me put here inverse function of f of x. Okay? All right. So I'm rewriting 2y plus 7 is equal x. And then I'm going to find y. 2y is equal x minus 7, right? And dividing by 2. Y is equal x minus 7 over 2. So this is inverse of f of x. Next example. F of x, which is same thing, equal y, equal 4x cubed minus 1. It's too thick. So replacing again, x is equal 4y cubed minus 1. So we need to find y from here. So I'm rewriting 4y cubed minus 1 is equal x. From here, 4y cubed is equal x plus 1, right? Dividing both parts by 4. Okay. This 4 is gone. So y cubed is equal x plus 1 over 4. And we have to take cubic radical because we have here degree free. So we have to take cubic radicals. So it's going to be cubic radical of y cubed is equal x plus 1 over 4. So from here, cubic radical of y cubed, it's coming y out. That's equal cubic radical x plus 1 over 4. And this is a inverse function of f of x, which means cubic radical x plus 1 over 4 is inverse for 4x cubed minus 1. Okay? It's inverse for 4x cubed minus 1. So this is the function. Cubic radical x plus 1 over 4. And it is inverse of 4x cubed minus 1. Another one. Let's say y is equal f of x, and it is equal x plus 1, x minus 5. Well, we need to mention that x cannot be equal 5, yeah, right? Okay, so what we are going to get here, replace to get the inverse. It's gonna be x is equal y plus 1 y minus 5. So from here I'm going to bring to common denominator, since this is equation x is equal y plus 1 y minus 5. Common denominator is going to be y minus 5, right? Therefore here it's going to be y minus 5, and on the top also y minus 5. So since in the equation, when both across the equation the denominator is the same, so we just simply drop it, and we are going to have y minus 5 times x is equal y plus 1. So from here, multiplying yx minus 5x is equal y plus 1. So I'm going to move y on this side because I need to solve for y, right? So yx minus y, and that is equal, 5x moving here, will be 1 plus 5x. Okay, taking y out from these two terms will be x minus 1, right? Will be left 1, and I will have 1 plus 5x. So from here I need to get rid of x minus 1 because I need to find y, so therefore I am dividing by x minus 1, and because whatever the change I do to one side of equation, I have to do same change to the other side of equation. So this is gone, and my y is equal 1 plus 5x over x minus 1, and this is inverse of function f of x, or 1 plus 5x over x minus 1 is an inverse of function x plus 1 over x plus 5, x minus 5, x plus 1 over x minus 5. Okay? All right. Next, let's identify how to test. So we algebraically learned how to test if two equations are inverse or not. It's right here. We did that. Right? If both functions we take composite and we get the same result, then it is these two functions are inverse. How we figure out by graphing if the given function has inverse or not. So inverse function graphically. So it's a horizontal test. Okay. So let's see. Let's assume we have graph. To identify if this graph has inverse the function, if this function has inverse one, we are going to provide horizontal line no, hold on. Providing horizontal line and if it's crossing only in one place, in one spot only, then the graph has an inverse function. Next one. Well, let's assume we have this type of graph. Okay. Providing straight line. Well, it's crossing in more than one places, right? Two places. Therefore, no inverse function. this function doesn't have inverse. But if my graph would look like this, then this graph would still not have inverse function, right? I'm sorry, I am providing horizontal line. Vertical line, it's supposed to be horizontal. Remember, when do we use a vertical line? To identify if it's function or function, right? Horizontal line we use for identifying if the function has inverse. Okay, it's crossing only in one spot, which means has inverse function. And then let's say we have such example. So if I provide horizontal line, it's crossing only in one spot, then it has an inverse function. Okay. So we learned how to find the inverse of the function algebraically by replacing x, switching with position x and y, and then solving for y. Now let's see how to find the inverse of function by graphing. Okay? So let me see. This is going to be my graph. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to write down the coordinates that we are going to use. So let's say we are going to use coordinate 0 and 2. And then we are going to find coordinate 2 and 5. And then it's going to be 4 and 5. Okay, so let's build the graph. So 0 and 2, 1 and 2, it's right here. And then next point is going to be 2 and 5. This is 2. Okay, I'm sorry. It's not 2 and 5. Hold on. It's gonna be one and 3. So 1 and this is 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. And then lastly, we're going to have 4 and 5. This is 4, it's gonna go up 5, it's gonna be right here. All right? Okay, so graph is gonna look like this. Okay? Now let's see how it's gonna look inverse. For inverse, what we're gonna do? We are going to switch x with y, which means 0 and 2 will go as 2 and 0. 1 and 3, it's gonna go 3 and 1. And 4 and 5, it's gonna go 5 and 4. Okay, let's build it. 2 and 0, it's right here. And then 3 and 1, it's gonna be right here. And 5 and 4, okay, so the graph is gonna look like something like this. So in this case, okay, and in this case, x, this is your, I'm coloring this point so you can see. So this blue point on the blue one, it's inverse of blue point on the yellow graph. Red point on the blue one is inverse to the red point on the yellow one. Okay, this is the first graph. So this one is, if this one is f of x, then this one is f of negative 1 of x. Hold on. Let me use blue color so it will look better. F of negative 1, f of x. Okay. Next one. Let me write down coordinates. So 1 is going to be negative 3, negative 2. And then we are going to have negative 1 and 0. And then we are going to have 4 and 2. Okay, let me build here, bring on graph. No. That's not what I wanted. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. Okay, let me build on this at the same time the inverse that it's going to be on this side. So inverse point, it's going to be -2, -3. And then red one will be 0 and 1. And green will be 2 and 4. Well, we do switch positions, x and y. So this is our graph. So let's build our point, -3, -2, -3, -2. This is our blue point. And then red one, -1, -1 and 0, right here. And 4 and 2, +4 and 2. Okay, so our graph goes like this. Well, maybe, let me see. Okay, this is better. All right, now next one, -2 and 3. X is -2 and the -3. So it's going to be right here, -2 and 3. Okay, and then 0 and 1. Wait, if -1 and 0, then I'm sorry, it's going to be 0 and -1. Okay, let me see. So it's going to be 0, -1, which is coming here. And then 2 and 4. So this is 2, 1, 2, this is 4. So this is 2 coming 4 right here. Okay. So graph is coming like this. And then from here is coming here like this. So if this is my f of x, then this yellow one is f of -1 of f of x. Well, let's pay attention. We have here point. Let me see what color to take at this point. So inverse is going to be equal to each other, right? It's going to be the same. We're going to be equal function. So whatever form f of x has, whatever value it has, inverse is going to be the same because they are crossing there. All right. Next one. Let's assume we have this following graph. So what points do we have here? -1 and 0.5. And then we are going to have 0 and 1. And then we are going to have 2 and 4. Okay, so let's find out. -1, 0.5. Inverse is going to be 0.5 and -1. And then 0, 1, inverse is going to be 1 and 0. And 2 and 4, inverse is going to be 4 and 2. Well, let's build the points. -1 and, okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, whatever. So, -1 and 0.5, it's going to be somewhere here, right? Okay, red one, it's going to be 0 and 1. It's right here. And 2 and 4, this is +2, it's going to come right here. So this is how our graph is going to look like. Okay. Now let's go with inverse graph. 0.5 and -1. It's going to be right here. 1 and 0. 1 and 0, and then 4 and 2. 4 and 2. Oops. So in the graph, it's going to look like and this is going to be the inverse. Okay, so here we have f of -1. Here we have f of x and inverse of f of x. One more. So you will see it's not always it's going to be symmetric. This is interesting one. So okay, so we have -2 and 4. -2 and 4. And then green one, -1 and 2. And red one, 0 and 1. So let's see. Let me start with red one. Since I have red one, it's going to be 1 and 0. And then green one will be 2 and -1. And the blue one, it's going to be 4 and -2. So let me build position. -2 and 4. This is 1, 2, 3, 4. 1, 2, 3, 4. Okay, so negative 2 and 4, it's going to be right this. Green 1, negative 1 and 2, and the red one 0 and 1. So the graph is going to go like this. Okay. Okay. Now let's go with the inverse of this. It's going to be 4 and negative 2. This is 4. Negative 2 will come here. And then 2 and negative 1. It will come right here. And then 1 and 0. And the graph here, it's going to go like this. Okay. And this is going to be our inverse. And this is f of x. Okay, hopefully this will help, and I'll see you at next recording.